Hello, my name is Srini, and today we're going to learn about the Richter Scale. So what exactly is the Richter Scale? Well, the Richter Scale was developed by Charles F. Richter in 1934. He used a formula based on amplitude of the largest wave recorded on a specific type of seismometer, and the distance between the earthquake and the seismometer. The scale is specific to California earthquakes, but other scales based on wave amplitude and total earthquake duration were developed for use in other situations, and they are designed to be consistent with the Richter Scale. So now we know a little bit about Richter and where the Richter Scale came from. We can learn about how exactly earthquakes are measured with the Richter Scale. The Richter Scale is a numerical scale for expressing the magnitude of an earthquake on the basis of seismograph oscillations, which is it's kind of like a pin, and when it does a little like a little rumble, it goes up and down, and the bigger the rumble, the bigger the thing. All right. So it's pretty basic explanation of it, I think, right? The more destructive earthquakes typically have a magnitude between 5.5 and 8.9 on the Richter scale, while earthquakes between 0 and 4 are typically unfelt, and they happen all the time. Like, honestly, there's probably a 1. Actually, there is. There is a 1 earthquake happening right now. I mean, they happen every minute. So, you don't feel them. The Richter scale is a base 10 logarithmic scale, which defines magnitude as the logarithm of the ratio of the amplitude of the seismic waves to an arbitrary minor amplitude. For example, as measured with a seismometer? Dang. Anyway, you know what I'm talking about. An earthquake that registers 5 on the Richter scale has a shaking amplitude 10 times that of an earthquake registered of 4. And that also means that, and the release of energy is approximately 32 times that release of the lesser earthquake. So just a difference between a 4 earthquake and a 5, there's a 32 times the energy, 10 times stronger, and that's actually quite a lot. That's more than I would expect it to be, right? So now that we know that the logarithmic equation, dang, I messed that one up real bad, right? Alright, now that we know that the Richter scale is a logarithmic equation, we can talk about how logarithms are used in the Richter scale. So, the Richter scale is R, which stands for the Richter ratio, equals, it equals log amplitude of the earthquake being measured divided by the lowest amplitude of the, hold on, let me move this one over a little bit so you guys can see. Alright. So this is the logarithmic equation for the Richter scale. R is for the Richter scale measurement, and A is the measurement of the amplitude of the earthquake that the earthquake was, and A0 is the amplitude of the smallest detectable wave. So now we're gonna start off with kind of an example. So let's erase this real quick so we have room to write. So now let's say an earthquake is measured with a wave amplitude of about 392 times as great as the A0. So what is the magnitude of this earthquake using the Richter scale? So we're going to start off with, so what we're going to do is we're going to write out the equation. R O, no, not R O. Dang, missing this one up. All right. R equals log. Alright, so now we know that the amplitude is 392 times greater than the original. I'm going to move this over again. Alright, excuse the bad handwriting. Alright, so now that we see here, we're going to cross this out. And so now we're going to have 392. And if we solve this out, the log of 392 is 2.6. So this earthquake has an amplitude of 392 times greater than the original, which means that it will register as a 2.6 on the Richter scale. Now this earthquake, according to this chart, according to this chart, you can see that 2 is not felt. So, but this is a 2.6, so it may be felt by a few people. According to 3, it may be felt by a few people, but you're likely not even going to notice it. So, two famous earthquakes would be the one in Japan. That was a 9 on the Richter scale. And the one in Nepal was 7.1. And both of those took thousands of lives. If you look at the chart, it actually says a 9 would be very disastrous. And a few buildings survive, bridges are damaged or destroyed. All services are interrupted. And the one in Nepal is ruinous. And some houses collapse, pipes break. But obviously you can see the one in Nepal did far more damage than that. So, thank you for learning about the Richter scale. I know it's kind of a short video today. Thanks for having me. I hope you learned a little bit about the Richter scale. I know I did.